So this lesson mostly focuses on slope of a line. But it's kind of more of like a slope sandwich, right? We just got done talking about slope and identifying slope in an equation. It's whatever's with that x variable, not including the x, but the coefficient in front of the x. And we're going to talk about slope again next video in a lot more depth, actually. But inside the peanut butter center here of this slope sandwich, we're talking about intercepts. Okay, so let's start off by defining what an intercept is. And we talked about intercept a little bit last lesson when we were looking at Desmos. It's one of the key things that our graphs show us. When we type in a function and you click on the graph, it will show kind of grayed out points. It shows max and mins and then x and y intercepts. Okay, so we've talked about these a little bit, but what is the definition of an intercept on a graph? And that is the point where the line or curve crosses the axis of a graph is called the intercept. Okay, so two things here. Now, if it wants to know just intercepts, it's just where it crosses the x and y. But if it wants specifically, what is the x-intercept, what is the y-intercept, and sometimes we want just one or the other. Here's how we tell the difference between them. So if a point crosses the x-axis, then it is called the x-intercept, and if it crosses the y-axis, then it is called the y-intercept. Okay, so I made two very basic examples here. So here's first of a linear. So we can see here is my x-axis, and here is my y-axis. So where is it crossing this x-axis at? Right here. So this is an intercept. More specifically, this is an x-intercept. And where is it crossing the y-axis? It is crossing right here. Now, more specifically, it is an intercept, but the specific name for this point would be the y-intercept. They are both intercepts, but this is your x-intercept, this is your y-intercept. Okay, so in this example, we have one x and one y. Here's another example of something we could see. So again, here's my x-axis, here's my y. Where is this one crossing on my x-axis? Well, it is crossing 1, 2, 3 places. So these are all x-intercepts. Okay. And where is this graph crossing along my y? It's crossing right here. So this would be my y-intercept. So this time I have 4 different intercepts, 3 x's and 1 y. For this class, since it is functions and modeling, we will only ever have one y-intercept. Because if we have more than one along this y, then it's not a function because it doesn't pass that vertical line test. Now, technically, as you go on to other classes, you can have multiple y-intercepts, but for this one, it will just be the one. However, the amount of x-intercepts can change. Here's an example of 3. Before, here was an example of 1. We could have 2, we could have 4. Okay, it doesn't, there's not a number that it can't be, I guess. But we will only have one y. But what's the difference between them? Where is it crossing that x-axis or x-intercepts? Where is it crossing the y or the y-intercepts? Okay. So now that we know what intercepts are, how do we find these algebraically? So we're focusing on linear functions in this section, but I do want to make note that this is going to work for any kind of function. So when we go on to module 2, we talk about quadratics, and we go on to exponentials and logs and cubics and quartics. The same thing works for all of these functions. But for us specifically on these linear, when given an equation of a line, to find the x-intercept, if there is one, we will let y equal 0, and then we will solve for x. So then opposite. If given an equation of a line to find now the y-intercept, if there is one, we're going to let x equal 0, and then solve for y. We're going to come back over here and do this finding intercepts and desmos, but first we're going to do this algebraically. So in our next piece of paper here, page 19, and I have to sneeze. Oh, I hate that feeling. It went away. Okay. So example 3, a new car worth $48,000 is depreciating. So it's going down in value by $8,000 per year. The mathematical model, which describes the car's value y in dollars after X years. So get in the habit of underlining what X and Y are representing. Is, and so here is my equation. So this should make sense. I bought the car for $48,000. So that's my starting value. Because it is decreasing by $8,000 per year, that means multiply. So we have 8,000x, and depreciation means we have a negative slope. So first, find the x-intercept. Describe what this means in terms of the car's value. So to find the x-intercept from that previous page, to find the x, we're going to let y equal 0 and solve for x. So we're going to have y equals 0 here. So in place of this y, I'm going to put 0 and then rewrite the rest. And now solve for your x. So I have variable and constant on one side. I need to move one of these over. So I'm going to add my 8,000x. Negative 8,000 plus 8,000 cancels out. So we have 8,000x equals 48,000. Get x by itself, we will divide by 8,000. And so if we put that in our calculator, or really we don't need to, these zeros cancel, these zeros cancel, these zeros cancel. What's 48 divided by 8? And that will be 6. So find the x-intercept. We have x equals 6, which would be the ordered pair 0, 6. I said that backwards. 6, 0. Okay, I know that for 2 reasons. Let's just go with 1 reason. I mean, I found what x equals, right? X equals 6, so that needs to go in my x place. And what did we put in for y? We said that y equals 0, so y is 0. Now, not only do I need to find the x-intercept, but I also need to describe what this means. I'm going to do it for this one, and then you guys are going to pause the video and try to do it here for B. My x is 6, and I'm told that x is the number of years. So, in 6 years, what does my y represent? Y is my car's value. The car will be worth nothing, $0. Okay. Part B, find the y-intercept. So do the opposite. With y-intercepts, we're going to let x equal 0 and then solve for y. Now we have x equals 0. So I'm going to replace this x with 0. Y equals negative 8,000 times 0 plus 48,000. Well, this one's nice and easy with that 0 right there. 0 times anything goes away. That zero's out. So I simply have y equals 48,000. Okay. As an ordered pair, we had x was 0, and we just found y to be 48,000. Describe what this means in terms of the car's value. So pause the video and see if you can tell me what this means. Okay, hopefully you had time to pause the video and try this on your own. If not, it's kind of your last chance. But I have the ordered pair 0, 48,000. So my X is 0. What does X represent? X equals the number of years. So after 0 years, my Y represents the car's value. The car is worth $48,000. Now, the way I just said that, if you wrote that, that's fine. In 0 years, the car is worth $48,000. But we don't really say in 0 years, right? So I wrote the car's initial worth was $48,000. But as long as you kind of understand what everything is representing, then that's good. This isn't the only way to write that. Now, here can be a reason why it is so useful to find some intercepts. Part C says use the intercepts to graph the linear equation. Because X and Y must be non-negative, limit your graph to quadrants 1 and its boundaries. Okay, so what does that mean? When you have a graph here, you have 4 different quadrants. You have quadrant 1, goes counterclockwise, 2, 3, and then I always get 4 backwards. What is it? 4. Okay. It wants us to limit this to only quadrant 1. Well, why? If my X is representing years, I can't go before 0 years. If you go before 0 years, if you go past today, we're talking about time travel here. If you know how to time travel, come talk to me. I also can't have Y, which is my car's worth, be less than $0, right? So you might say the car is hardly worth anything and it needs a new engine and it needs new brakes and it needs new, I don't know, about the only car parts I know, right? But even if you're putting money into the car, and yes, it's costing you money, when you sell it to somebody, you're going to at least make $200 off of it or something, right? So that car's worth isn't going to be less than here. You're not going to say, I'm going to give you $500 to take this car from me. So we need to limit this to quadrant 1 because my time needs to be positive and my money needs to be positive. So here's where we are here. And this axis here, let me get a black pen, is representing my years. That's my x-axis. And then my y-axis is representing my car's value. Okay, we're starting right here at 48,000. And we are going to 6 years right here. Therefore, my line would be that right there. So here is my graph. Okay, now let's go back to that first page. And here's how we find the intercepts in Desmos. So I already have this graph, so that should look familiar. That's our 48,000 and our 6 right there, right? And really, we've already done this, so this isn't going to take super long here. I'm going to type in the equation that we did. So it was this y equals negative 8,000 plus 48. And because we've already graphed this and found those intercepts, I know what I need my balance to be. So I will go in here and I know we just need to 6 years. And let's maybe go a little bit past it. So let's go to 7. And we're at 48,000. Or yeah. So let's go to 50. And here's kind of my graph here. So once we typed in the equation and kind of fixed our window here to make sure we have all the juicy information we're looking for, click on anywhere on the graph and you'll see these two gray points again, right? Click on the gray points that cross the axis. So here's one at 0.6, and here's your other one right there at 0,48,000. So those are our X and Y. So to be able to find this, type in the equation, make sure you can see where it's crossing the X and the Y. Click anywhere on that graph, and then you'll see those gray points. And we're looking for points that are crossing at the X axis and points that right here are crossing on that Y.